In this video, we are still finding the perimeter and area of figures in the coordinate plane. So we are going to be on page 21 in your student journals. So in questions 9 through 14, we're going to use this coordinate plane here. And in number 9, it wants us to find the perimeter of triangle ABD. So here's triangle ABD. Perimeter is the distance around the triangle. So remember, we want to count our lengths whenever we can. I notice I can count the length of DB since it's horizontal. 1, 2, 3, 4, 5, 6. AB is 1, 2, 3, 4, 5. The only length I'm not going to be able to count is length AD. And so I'm just going to put my work off to the side of using the distance formula to find AD, because I might need it in another question. So I'm going to make sure I put down my work so I can have it for my other questions on the page. So AD, I'm going to label point A, which is 2, 4 with x1, y1, and I'll label point D x2, y2. And I'm going to use this in my distance formula. So remember, the distance, the length of AD, is equal to x2 minus x1 squared plus y2 minus y1 squared. You should start getting better at using the distance formula, so I'm going to go a little faster through this. You can always pause it if you need to. So I'm going to plug in my values. x2 minus x1 gives me negative 4 minus 2. And y2 minus y1 gives me negative 1 minus 4. I'm going ahead and doing that subtraction. Square root of 61 is approximately 7.81. So now to find the perimeter of this triangle, I'm going to take those 3 lengths I just found and add them together. This gets me approximately 18.81 units. We're going to skip number 10 to save a little bit of time, and we're going to move on to number 11. We're going to find the perimeter, so the distance around quadrilateral ABCD. Okay. This is one where I can use this length I've already counted. I have found this distance, which is 7.81, but I still need to find these distances. So we are going to have to use the distance formula again, twice. Okay. So first I'll find the distance between B and C. So remember, point B is at 2, negative 1, and C is at negative 1, negative 5. So I need to use these x and y coordinates in my formula. So I'm going to label these here for myself. Okay. This is going to be equal to, I'm going to use this formula over here. I'm just going to look over here, so I'm not going to keep writing it a bunch of times. x2 minus x1 is negative 1 minus 2. And y2 minus y1 is negative 5 minus negative 1. -5 minus -1. Remember, that's the same thing as adding. The square root of 25 is 5. I don't have to round that one. So I'm going to put that distance right here, that length in my picture. I'm going to do it one more time to find the length of DC. I'll put my work over here. So remember, point D is at -4, -1. Point C is at -1, -5. So I'm going to use those points now. Okay, my distance formula, length of DC. Again, you can go back up here and use this as a reference. Y2 minus Y1 is -1 minus -4. Y2 minus Y1 is -5 minus -1. I'm going to turn those into big plus signs. And you'll notice that this side of the quadrilateral is also 5. You might have been able to tell that by looking at it, but I think I kind of messed myself up with my my highlighting, so I didn't want to assume, but those two sides are the same. So now I'm able to find the perimeter. So the perimeter of my quadrilateral is 5 plus 5 plus 5 plus 7.81. And that gets me a total of 22.81 units for my perimeter. Now we're going to find the area. So now we're thinking area formulas. So in number 12, we want to find the area of triangle ABD. So I'm going to use my formula for the area of a triangle, 1/2 times base times height. Triangle ABD is this top triangle. The base is this flat part that it sits on. That has a length of 6. And the height of my triangle is 5. So the area 1/2 times 6 times 5 is 15 square units. The area of triangle BCD, that's this triangle down here. And now this one, for some of you, it might be hard to picture what the base is. The base is this flat part. You could imagine flipping your paper over, and you could turn that triangle upside down, and there, now it's sitting on the base, right? If you like to think of it as the triangle sitting on the base. So the base is 6, and the height, remember, is the length from the base straight up to the top, that length that is perpendicular from the base to the point. And so this is just a vertical line, so I can count this height. I'm going to flip it back over. But this length is 1, 2, 3, 4. So to find the area of triangle BCD, I'm going to take 1/2 times the base, which is 6, times the height, which is 4. 1/2 times 6 times 4 gets me 12. So the area is 12 square units. And number 14, find the area of quadrilateral ABCD. So this quadrilateral is not a rectangle, so I can't use the area formula for a rectangle. But remember, the area of a shape is the space inside. We have already found the area of this triangle, and we've already found the area of this triangle. So you'll notice together they add to make the total area of the quadrilateral. So this one, to find the area of quadrilateral ABCD, we just need to take the area of the two triangles and add them together. So the area of quadrilateral ABCD is 27 square units.